Okay, talking about large versus small sum of squares for the model. On the sum of squares model, sum of squares PowerPoint, we saw this drawing here. And what this indicates is all the dots. Right, so all those dots are our data points. And this vertical line, or the horizontal line, sorry, is the mean. And the line here is essentially the model. So if you have very, very small sum of squares, so let's redraw. We're going to keep similar types of data points, and we end up with a model that looks like this. So we have very, very small deviations. So it'll tell us that the regression model is a little bit better than using the mean, but not much. Whereas if you had a large deviation from the mean, and when you look at this, it looks to fit the data points better. That means it actually is better, much, much better than the mean at predicting the outcome. Whereas this model has a small model sum of squares. So this is a poorer model, and this one here is a much better model. Again, because the deviations from the mean to the model are so small, you might as well just have used the mean. Here, the deviations from the mean to the model are large, which means the mean is not a good predictor of the outcome, which means the model, which would be the diagonal line, is a much better predictor of the outcome. And you can kind of see that when you look at the data points in the large sum of squares. That model does represent the data much better than this small line on the top. That is a pretty crappy representation of our data, which is in that range.